So here we will continue for conversion of hexadecimal number to binary and then to decimal. First convert directly from hexadecimal to decimal number system by summing the weight of all digits. This is 6b2 hexadecimal number that is represented in binary number system as shown over here 0110 1011 0010. Now we will see the binary logic that is utilized in computing systems. The two voltage levels can be represented as two digits, digit 0 and digit 1. As you can see here, the voltage levels is shown in the scale from 0 to 5. 0 is our 0 volt. We can consider it as ground voltage. Then 5 is the 5 volt, which can be considered as a VCC, plus VCC. We can see here the logic 0 is represented by ground voltage level and logic 1 is represented by the voltage level ranging from 3 to 5. In general, we can consider that logic 0 is 0 volt and logic 1 is VCC volt. In this case, it is plus 5 volt. A valid digital signal should be within either of the two shaded areas that are shown for the voltage ranges. It means that when we say it is 0 volt, it is not exactly the 0 volt, but it can be in the range of 0 to 0.8 volts. When we say that it is plus 5 volt VCC, it is clear that it is logic 1 that is ranging from voltage from 3 volt to the 5 volts. Here we will see the review, or here we will see the introduction of logic gates. The first and basic logic gate is AND gate, that is represented over here. This AND gate has two inputs A and B, while it has one output, that is X. The relation between the output and the input is given or in the form of Boolean expression, that is X is equal to A dot B. A dot B, it means that it is the OR operation. It simply means that the X will be high if and only if A and B, both the input signals are high. High, it means that when A and B are 1, X will be 1. Otherwise, the X will not be 1. X is the output in this case. The truth table representing the AND gate operation is also shown over here, that has two columns A and B and output column, that is X. It directly represents that when it is 0, 0, output is 0. When it is 0, 1, output is 0. When it is 1, 0, output is 0. When it is 1, 1, output is 1. After that, we see the OR gate. OR gate also has the same concept as the AND gate. It has two inputs, one output, AB are the input and X is the output. The relationship is represented by Boolean expression, that is X is equal to A plus B. Now we'll have to understand the basic operation of OR gate. It means that if A or B, any one of the input is 1, then your output X will also be 1. Otherwise, output X will be 0. That is clearly indicated in the truth table. It is when input A and B both, any one of the input is 1, then your output is 1. Otherwise, your output is 0. We can see here clearly that when A is 0, B is 0, output is also 0. For all other three conditions, output is 1, 1, 1. Okay. Similarly, there is a tri-state buffer inverter. Inverter